All right, well, welcome to this JMP academic webinar on resources for teaching and learning JMP. I am going to cover a lot of resources today, so if all or most of the information I'm showing is new to you, or if you're just a little overwhelmed when I undisclose one of these buttons and show you 50,000 links, I'm going to try to keep anchoring back to some key places where you'll be able to find everything that I'm talking about today in just a couple of simple places. So I'm going to show you a lot, but I'll try to keep reminding you where to go find those things again. And the first of these anchors is here at the top. If you only remember 3 things from this webinar today, one of these is the JMP Help menu. There are many great resources and teaching tools built into the JMP Help menu. You can see the JMP menu bar along the top. Here in the Help menu, we're going to spend some time here. We'll explore a few of these resources, but we'll especially spend some time in the teaching resources that can be found here under Sample Data. And then in addition, we'll also spend some time on our academic webpage, jmp.com/teach. There are many resources available there. Many of these resources were developed by our academic team, but there's also a lot of great resources here that have been developed by other professors and faculty who are teaching with JMP. So we'll definitely spend a little bit of time on the webpage exploring what's available there. And then this webinar is being recorded, so you can find the recording of this webinar as well as this outline that I'm using here on the side, including all the links that are embedded here, by going to the jmp.com/teach page and then clicking on Academic Webcasts and Academic Webinar Library. And I want to mention that this outline that I'm using is called a JMP journal, and it's a file type that exists in JMP. The file extension is a .jrn, like journal extension, and so you need to have JMP in order to open this journal file. I find these JMP journals incredibly useful for collecting an outline for a talk or for embedding JMP output, for embedding links to JMP data files, even links to other URLs. If you want to create a journal like this, you can start with a blank journal by going to File and New Journal, and that will open a blank file for you, and then you can start populating it with your own output and your own outline. Okay, so before we dive into the meat of this webinar, let's take a very short tour of JMP. JMP is a family of 5 products. If you're using JMP at a university, you are likely accessing our JMP Academic Suite. The Academic Suite includes 2 products, JMP and JMP Pro, and these are available on both Mac and Windows as separate downloads. If you have the choice between JMP and JMP Pro, I would always recommend just download JMP Pro since it's going to include everything that JMP has plus a little bit more. The Academic Suite also includes free access to JMP e-learning courses, and you can find links and more information about this. I'll show you a little bit later how you get access to those e-learning courses. I will be using JMP Pro in version 13 for this webinar. Version 13 came out in September, and so that's the current version. There's also a separate JMP Student Edition, which still contains all the built-in resources that I'll show today. If you're using the Student Edition or an earlier version of JMP Pro, 12 or sooner, you may see slightly different or shorter lists of menu options, but most things are going to look very similar to what I'm showing. If you can't find something that I'm talking about, just send me an email and we can tell you if it's changed in a version update or if it's located in a different place in your menus. And then there are also 2 additional products from JMP. JMP Clinical, which is for clinical trials, and JMP Genomics for genomics research. These products are a combination of the regular JMP product bundled with some SAS components. So when you're using JMP Clinical or JMP Genomics, you're actually using both JMP and SAS together. So let's open a data set, and I'll just give you a very brief tour of this data set. You can see that a JMP data table is a spreadsheet data table with some additional information in the side panel about the columns and the rows and some other anchored information up here. This SAT by year data set is one of approximately 500 data sets that come built into JMP. And this particular data set contains information on average SAT scores. So there's, let's scroll down. You can see there's SAT verbal and SAT math score, and some other variables that are related as well. And so the information is for each of the 50 U.S. states plus the District of Columbia. And then we have information for years from 1992 to 2004 in the data set. So you can see each state or the District of Columbia has 8 rows corresponding to some of those years from 1992 to 2004. So let's create some output for SAT verbal and region. So I'm going to go up here into the jump menu and I'm going to choose Analyze and Distribution to just look at a simple distribution of a variable. And I'll choose SAT Verbal and maybe SAT Math and Region. And I can either click on these and click this Y button to get them into this box where I need them, or I can drag them into this box. I can say OK. And now I see some output for SAT Verbal, for SAT Math, and for Region. A few things to know about JMP, and I'm going to open these to show you this. JMP is very focused on visualizations. So when you get output, if there's a visual we can give you, we're going to give you a visual. And it's also dynamic and interactive. So if I click on a point or a group of points like this bar, you're going to see this data highlighted in all the other plots and also back in the data table. So the data that I've got highlighted in the plots is also going to be highlighted in the data table. If I click on South, I'll see that data highlighted. So I can actually see right here that the South region is a really interesting region in this data table because the math and verbal scores, there seem to be, it's a bimodal distribution within the South. So maybe the South is not a good way to describe that region. Maybe there's really two subpopulations here in the South that we'd want to talk about. So this dynamic and interactive ability of JMP to show you data helps you find interesting information in your data a lot faster. Okay, JMP is also context dependent, so that means the analysis and visualization options that JMP presents are going to be dependent on the modeling type of the variables involved. So you can see that Region has some slightly different output than SAT Math and SAT Verbal do, and that is because of the modeling type of these variables. So the modeling type, we'll see a little icon in the data table next to the name of the variable. So we can see SAT Verbal and SAT Math have this blue triangle and Region has these red bars. The red bars indicate that this is categorical data, and specifically it's in name only categories, so nominal categories. I'd see green stair steps like this if it were ordered categories, and I see this blue triangle that's indicating continuous data when I have quantitative continuous data. So when I look at the output, JMP is context dependent, and so it gives me different output for the categorical variable than it does for these two continuous variables. You can also see under the red triangle options, and this is another important point about JMP, red triangles are how the progressive interface works in JMP. You'll always find additional drill down options under these red triangles. So under this red triangle here for SAT Verbal, you can see that JMP presents options like testing a mean, or getting a normal quantile plot, or testing different continuous distributions against this sample data. So I get things that would make sense in the context of a continuous variable. And then on the other hand, for Region, which is categorical, I'll get options like testing a probability or reordering the categories. So the modeling type of the variable will help determine the context and the options that JMP presents for analysis and for visualization. JMP is also very flexible in allowing you to visually explore data very quickly and interactively. The graph builder is a great tool to just play with some visuals and some options of how to look at data. I can do something as simple as grab several variables and just throw them in the middle, and JMP's going to make a guess about what is a possible plot for those three variables. I didn't give it any extra information about how I want to use them. If I wanted to be a little bit more clear about what I want, let's say I know that I want to use SAT Math to predict SAT Verbal, so I can drag into these regions. And then I see this ribbon across the top that gives me different visual options. Right now there's a smoother on these points. If I don't like the smoother, I could take that off. Or I could add this best fit regression line. I also get a little bit of extra information to do things with the points and with that line. For example, I can add a prediction interval. I can add the equation to the plot. I could add the r-squared. I can take another variable and drag that into more regions. And you can see as I drag it around, I get different options as I hover in different zones. I can put each region on a different page. I can overlay the regions. And then when I'm happy with a plot, I can click Done. I can export it by clicking that fat plus sign and just copying and pasting it somewhere. I can also go to File and export it in a number of different image file types or as interactive HTML with data into a Microsoft PowerPoint slide right away. So there's a number of things I can do with my output right away. Okay, so let's now look at some of the resources that are built into JMP. And I'm going to start there. I'm going to show you resources in sort of 3 different bins. I'll show you things that are built right into the software. I'll show you some things that we have on our academic webpage. And then I'll show you some things that are hosted in our user community that are user contributed resources, a lot of teaching tools and syllabi from classes and things like that. So we'll start with the built-in resources in JMP, and we'll start specifically with this help menu in JMP. So getting help in JMP, a lot of these tools are right in the help menu, so they say help and then lead to something else. So I'll talk about sort of in order what's in our help menu. First of all, there's a searchable JMP help. If I click on this, this will take me to the online help, and I can search for a term here, for example, distribution. And it'll pull up options for me that have to do with distributions in JMP. And so if I wanted to fit a specific distribution, like I get some information on the beta binomial distribution here, or the continuous fit for distributions that we saw from that SAT verbal drop-down, drill-down red triangle menu. So the searchable help is right there in JMP in the help menu. Also, the books is JMP's documentation. If you want to see all of the documentation, you can go to the documentation library to see one big PDF. But it's also split into types of things you might be interested in. So if you want to learn more about graphing and using Graph Builder and other graphical features in JMP, you can use the Essential Graphing book and walk through the table of contents to find the types of things you want to learn more about. There are a lot of examples built into these books. A lot of them are built on sample data sets that are available within JMP, so you can immediately open the sample data set and imitate the same example that's being shown. So that's the documentation. The sample data library is an alphabetical list of all the sample data sets that come with JMP. So if you know the name of a sample data set, you want to go to sample data library and you can access those right there. New features is just a list of new features in the current version. So version 13's new features are described here. The JMP user community button just pops you right over to a URL for our JMP user community where you can search for more information. So if you're looking for a randomization test add-in, for example, which I'll show you in a little bit, you could go over to our user community and then search for that there. I'll also talk a little bit more about the tutorials later. I love these for teaching. I think they're fantastic. So they're built in right here, places for students to go to get a very detailed example of how to do a test of one mean or confidence interval for one mean. Tip of the day is another of my favorite things in this help menu. So when you're brand new to JMP, you're kind of just trying to find what you need in order to survive. You're going to analyze, you're using these menus and the red triangles to drill down a little farther, and that's perfectly sufficient to get you a ton of stuff out of JMP. But when you want to start becoming more efficient, you want to know how to edit your graphs more, change things on the axes, stuff like that, that's a good time to go back to the tip of the day. The tip of the day will give you, I think there are 58 tips in JMP 13. They'll open automatically at startup unless you ask them to stop doing that for you, but you can always go back to the help menu and find them here. And they're just a great way to get more effective and more efficient using JMP. And then the statistics index and the scripting index are places to search for information that you're looking for. So if you know I want to find, how do I get a 3D scatter plot? You can search for 3D scatter plot. You'll see the JSL code, the JMP scripting language code that runs in the background. You could click on Run Example, and JMP automatically opens a sample data set that makes a lot of sense for this example. It opens the output, so you can play with it. And you can also click on Launch, and it'll take you right to the platform where you would ask for this Scatterplot 3D. And you'll notice the name of it here is Scatterplot 3D. That's because that's actually a top level option under Graph.
Thank you.
Okay, and then the scripting index, if you are starting to write JSL code and you want to find some example script to do something, if you need to make a list, This is the JSL code. You can click Run Example. You can get topic help to pop out to the website to get more information about this. And again, it's searchable. So if you are using the JSL, the scripting index is where you want to go. If you just want to know how do I use the point and click menus to find a specific statistic, the statistics index. And then when you're in JMP, there are a couple other built-in help features. So I just talked a lot about the help menu, but in addition, if you're just in a platform, you've gotten some output and you want some help here. So for example, I'm looking at SAT verbal and I want to know, what was this diamond doing? What does this mean? I can click on this question mark, and the question mark is visible from this menu. If you're using JMP, I'm using JMP on a Mac, obviously. If you're using JMP on a Windows machine, this menu will sometimes be hidden when the window is not very large. By default, that's going to happen in JMP. You can set your preferences to have that not happen. But if you can't find the question mark and you're using Windows, if you just hover your mouse sort of at this little edge here, it should reappear and then you'd be able to find the question mark. So I can use this question mark to click on top of something that I'm interested in and want to know more about, and it'll pop me out to the help menu that has to do with that item, so I can read about that confidence diamond that shows up in the outlier box plot. So the question mark is helpful, and also the hover help when you're clicking around on things and you want to know more about, for example, what is continuous fit of normal mean. You can just hover your mouse over something and the hover help will appear and tell you, so for example, log normal fits a log normal distribution. Weibel fits a 2-parameter Weibel distribution. And so stem and leaf displays or hides a stem and leaf plot. So if I click on this, I'll get a stem and leaf plot for that data. So the question mark to hover over something and find out more information about that, or the hover help if I just am hovering over an option to see what that means. So this one customizes the summary statistics displayed in the summary statistics report. If I click on that, I can choose additional statistics to display as well. Now I have the minimum and maximum. Okay, so there's a lot of built-in help. We're still going to spend a little bit more time up here in help under sample data, because there are a lot of teaching resources built in there. So we'll talk about some of these sample data features, these teaching resources, and some scripts that are embedded here. So I clicked on help and sample data, and this opens, so the sample data library again gives me the alphabetical list of all these sample data files. I can also get to those files by clicking open sample data directory here, or I can find them cross-referenced by types of analyses that make a lot of sense for that example. So if I'm teaching ANOVA and I want some good teaching examples for ANOVA, I can click here and see some cross-referenced example data files that are available in JMP that I can use to, for example, if I want to talk about one-way ANOVA, I can open the typing data file, and I have 3 different brands. I have their speed, and so I can do an ANOVA to compare the 3 different groups, their average speed. So there's a cross-reference of all these things we might be interested in to do with sample data sets. But let's spend a lot of time right here in teaching resources. This is where we can get things that a lot of teachers are using as maybe Java applets. These are built right into JMP. So first I'll click on examples for teaching, just shows again some data sets that we think are particularly great for introductory statistics teaching. Teaching scripts includes 2 categories, these interactive teaching modules and these teaching demonstrations. I'm going to actually start down here and show you a couple things in calculators and simulations first. So I'll show you simulations. If I click on the central limit theorem, this just opens a data table. If I click into the notes, this tells me what to do about this. It says it's going to generate some distributions for me. It's a uniform to the 4th. Add about 30 to 100 rows and use analyze distribution of y's to see the differences. So if I go to rows and add 100 rows, and then continue following the directions, go to distribution, put in all of these into y. This lets me see, this is the actual distribution because these are samples of size 1. This is if I take means from samples of size 5, from samples of size 10, of 50, and 100. So I can see the central limit theorem working. As my sample sizes get larger, my distribution gets more and more normally distributed. So there are some of these simulations available. The calculators are ways to have your students actually do the calculations of a confidence interval or a sample size calculation or a hypothesis test. So for example, a hypothesis test for two means, if I want to input raw data, I can do that from an open data file, or I can use summary statistics. This is often, introductory problems often have summary statistics and ask students to calculate the values, the test statistic. So here I can input my summary statistic. So maybe I'm hypothesizing that the difference is 0. I want to test against a null of 0. My first sample mean is 3.5. My second sample mean is 4. And maybe my first population standard deviation is 1. And my second, oops, this was my sample size. I'll put this as 4. My sample size is 20. Maybe I'll have the same sample size for both groups, and I'll have the same standard deviation for both groups. I can set my significance level, and then you can see I get the observed difference between 3.5 and 4 was 0.5. I get a standard error of the difference. I get the z-score. I get what the critical value would be, and I get the p-value associated with this test. This is assuming that I'm doing a two-tailed test. I could also click on this for one-tailed or the other tail. I can reveal the decision. So here it tells me fail to reject the null hypothesis. And I can even choose, am I doing a z-test or a t-test, and how will the value change depending on z or t-test. So the calculators allow students to use summary data or raw data to create confidence intervals, to test sample size, to do hypothesis tests of these typical intro stats things. But some of the cooler, more fun things, so that's something that students need to learn and are going to use, but some of the fun interactive teaching modules and teaching demonstrations live up here. And so I'll show you a couple of these. First, I'll just mention a lot of people ask for dot plots, so there's a dot plot teaching demonstration. Dot plots are not living natively anywhere else in JMP, so if you wanted your students to create a dot plot, this is where you'd find that. Normal versus t just lets you show that the more the degrees of freedom, the closer that the t gets to the normal. So there's some simple things built in here. But I really want to show you the distribution calculator. So this is where students, instead of having to look up in a table in the back of a textbook or online, they can find critical values and p-values based on any of these distributions. So in ANOVA, for example, they'd be comparing to an F distribution. They'd have to specify the numerator degrees of freedom, the denominator degrees of freedom, and at some point we even talk about F distributions with a non-centrality parameter. So they can set this information and then they see the picture of the F distribution. They can ask for either input the value to get the p-value, or input the p-value or the probability to calculate the critical value. And we can ask for, are we looking at or below a certain value? Are we looking just above a certain value? Are we looking between two values, maybe from 1 to 2? Are we looking at the two tails outside of that region? And so the distribution calculator lets you do this for the normal distribution, the t-distribution, the chi-squared, and even a whole bunch of other distributions as well. Okay, I also love, so the demo mean for power and p-value are kind of interesting, but they're also built in, so I'll show you that built into another example. Well, I'll click on it right now. So here's looking at the power, and I can alter these guys to see a demo of this, but I'll show you where this is embedded just naturally in the software as well. So if you want to find it on its own, here power and p-value are right here. Let's look at the sampling distribution of sample means. This is another really fantastic teaching module. So I like to tell my students there are really 3 distributions going on anytime we're talking about a sampling distribution. There's the population distribution, so we get characteristics up here for the population. There's the sample, distribution, and then there's the distribution you're building of sample means as you take repeated samples. So this lets you choose a normal or skewed right or uniform, or just use your own data to sample from to get a population distribution. So if I wanted this to be, for example, IQ, I could have the mean be 100, the standard deviation be 15. I can change the sample size, so maybe I want sample size of 30. And first I'll start with just taking one sample, so I click this Draw Additional Samples button, and so I see. So the population was normal, centered at 100, standard deviation of 15. My one sample had a mean of 97.9, standard deviation of 13.65. It's just sample number one. So here's a picture of my one sample, and then I have one sample mean. That 97.9 got stuck into my distribution of sample means. So if I take a second sample, this is what my second sample looks like. Now my sampling distribution of sample means has two values in it. It has the 97 point something, and now it has 102.8. And I can keep doing this, and students can watch as I build the sampling distribution of sample means. And if I'm tired of clicking, I can ask to take a lot of samples at the same time. And so the students will see the standard deviation of this single sample is pretty wide, but the standard deviation here is much smaller. So I can see the standard deviation of sample means is 2.66, but the standard deviation of the sample was 17.79. So I can show them how I'm taking the standard deviation and dividing by the square root of the sample size to get down here. I can show them that relationship, and these axes are scaled the same so that it's really visually obvious to them. So this sampling distribution of sample means is really fantastic for demonstrating what a sampling distribution of sample means does. If I wanted to look at, for example, what a confidence interval means, I could choose confidence interval for the population proportion. And here I'm going to choose how likely a certain characteristic is. So I might say there's a 20% chance of the characteristic. What is the characteristic? I could say it's being blue. And so you'll see over here the options are then blue or not blue. So I could have heads and not heads. I could put whatever category name I want, and then the opposite is going to just be not that category. I can choose my sample size again. I'll take one sample to begin with, but I might increase that later. I can use this with the continuity correction or without to show students the difference, what happens. And so I'll draw a sample. And so in my first sample, I had 11 blue, 39 not blue out of 50. I can see what the actual sample proportion was. It was 0.22 instead of 0.2 from the population. And then I get one little confidence interval drawn right here. So far, 100% of my intervals included the true population proportion of 0.2. So this bar across this plot is showing me 0.2. And the interval, if it contains 0.2, then great, my confidence interval contained the true proportion. So if I do this a bunch of times, maybe I'll do 100 times. Now I can see that when I have a confidence interval that didn't contain the true population proportion, it turns red. So it's easy for me to see that most of the time, and if I'm doing 95% confidence intervals, it should be about 95% of the time, I should see these little green lines that are crossing that 0.2, and about 5% of the time I should see little red lines that are confidence intervals that were created that don't happen to include the population proportion. And so this is illustrating the true meaning of a confidence interval. Okay, so there's a lot of really cool things here. I'll show you a couple more that are really wonderful, and then you're going to need to spend time just clicking on things and experimenting. I'll show you demo least squares, and then how that's connected to demonstrate regression. So demo least squares allows you to add points and move the line around. So I can drag these little boxes and try to make my best fit line to fit these data. So maybe that's where I think the best fit line is. I can ask to see where are my residuals. So here's the distance from the points to the line that I created. I can ask for my squares. So it takes those and squares them and then gives me sort of a bar to show me how much my squares are adding up to. And I can do the same thing if I see what is the actual least squares line. So my line was kind of close, but it wasn't amazing. I can get rid of my squares if I want to, and I can instead look at the least squares residuals and the least squares squares. If I add mine back on, I can sort of see the difference, but they overlap a little bit. And I can see that the true least squares was less in the adding up those squares than mine was. So my line did not fit as well according to the criterion of least squares. So I can get a little bit more if I go to demonstrate regression. I can look at kind of the same sort of things, but I get more things I can play with. So in this case, I can even make my sample data set according to population characteristics. So here I have an equation for a line, y equals 5 plus 3x. I can change what these values are by clicking in the box or by using the sliding scale. So I can change my population characteristics. I can change what the mean of x is, what the standard deviation of x is. I can change the names of these things, revert to original, remove the last point that I add. I can change the sample size. I can draw a new sample from this same distribution. And then I can see what my line is. And I can continue drawing additional samples. So one cool thing I get to see is what it means to have these confidence bands. The idea that they're centered around the mean of x and that 95% of these lines should be in those bands. So I can talk about confidence bands. I can ask for more information, like let's look at all the intercepts from all my lines. Let's look at all the slopes from all my lines. And I can also add points. I can even create my own data set. So I could clear out all these points. I can make my own little picture of a bunny, and I can save that data set by going to Save Sample to Data Table. So this is also a really easy way if you just want to click and create a picture, create a certain shape. If you want to show a cubic shape and you want to create your own data set, you can do that really easily from this demonstrate regression by just using the red triangle above sample data and Save Sample to Data Table. So we've been talking about things that are all hidden under the Help menu in sample data, and then down here in teaching resources. So we talked about a lot of these teaching scripts, for example, the hypothesis tests, sampling distributions, confidence intervals, the distribution calculator. We spent a little bit of time in demonstrate regression, some of these teaching demos and calculators and simulations. So all of this stuff is incredibly valuable if you're teaching intro statistics or if you're learning intro statistics and you want to play with some of these ideas. So definitely spend more time going back to the Help menu and down in sample data to re-find these things that are like the applets that we used to use. Okay, so this is all built into JMP. And then you'll notice there's also a reminder to download more teaching scripts or add-ins. Visit jmp.com/tools. This will take you to a part of our academic webpage where we have a way for you to download these scripts and keep them in the add-ins as well. So you'll notice the same teaching modules that we just looked at here, I have under my add-ins. So if you are teaching with these and you want them to be really easily accessible, instead of having to go to Help, Sample Data, and then open these, if you want them just to sit in your add-ins, you can download them here. And you can find some additional teaching scripts and add-ins at jmp.com/tools. Let's talk for a second about add-ins. The first time you open JMP, you won't see this add-ins menu. You'll see this after you've downloaded an add-in. But add-ins can be simple things like a journal could be an add-in. If it's packaged up as an add-in, then when you click on the add-in, so for example, some of these some of these books have add-ins that come with them. So if I click on this Statistics Learning from Data by Roxy Peck, the add-in is just a simple journal that has all the data sets. So students can download that add-in and then automatically open example data sets this way. So add-ins are sometimes simple things like journals or just lists of information that you want to keep somewhere. Sometimes add-ins will include buttons and options to choose. And so as you become more comfortable in JMP, and especially if you're using the JMP scripting language, you might start creating your own add-ins, and you can share them on our JMP user community, and we would love that. And you can also search for other user-contributed add-ins on our user community. One of the add-ins that's available in our user community is this randomization test add-in. So I definitely want to show you this one. The randomization test allows you to select from the data sets that are built into JMP. So if I choose big class, for example, I can ask for let me maybe compare two groups. So I want two unpaired groups with a quantitative response. I'll use big class. I'll use height, and I'll compare the height of the boys to the girls. And so you can see I can generate a certain number of samples. I can change this number. I can choose either resampling, shuffling, or shifting. Resampling is going to keep the X the same. It'll keep the label of female or male the same, but it'll sample from the Y, from the height. Shuffling will do the opposite. It'll keep the Y the same, but it'll shuffle the labels of the X. And I can use this little question mark to learn a little bit more about that. I can set the difference in the means or in the medians to be 0 or some difference that I'm interested in, but if I want my null hypothesis to be that there is no difference, I set my difference as 0. You can see the data for females and for males. And if I click go, it now took 1,000 samples with the method of resampling. It built me a distribution, and it shows me the actual difference, which was negative 3.02 in this distribution here. I can ask to show the two-sided p-value, for example. And so that shows me the proportion that larger was about 0.022. And there are other options here as well. I could do a binary outcome event, one quantitative response. I could be, instead of looking at the means, I could look at the medians. I can choose from these data sets or use my own data set, and so on. So that's an example of an add-in that's available in our user community that might help you demonstrating things about randomization testing. There's also some really great randomization testing built right into the software. So if I wanted to do that same thing, I wanted to look at in the big class data, let's see where I have that. So I'll open this big class families data. There are two data sets called big class, one that's just called big class, one called big class families. But they both contain the information about the height and the sex, and that's what I want to look at right now. One fun thing about the families data set is that it also includes these embedded pictures. So if, for example, I look at a plot, I can pull out pictures of these students in this big class families data set. So that's really fun. So in this data set, if I still want to do a randomization test to compare the difference between the males and the females in their height, what I'm going to need to do is find a way to randomize this label of female or male. So the first step that I have to do is to create a new formula column where I'm randomizing the label for sex. So to do this, I can right click or control click, and I can select new formula column. I want to do this randomly, and I'm going to sample with replacement. So it created a new formula column for me where it's just resampling from the sex labels. So my first step is to create the randomization. My next step is just to do a normal analysis. So what I want to do is compare height on the two groups, female and male. So I go to Analyze, and to fit Y by X, because I have a bivariate type of relationship to a response and a factor, my response is going to be height. My factor is going to be sex. JMP gives me the visual right away, and then I use the red triangle to drill down and get something else. So maybe I'll do the pooled t-test here between these two categories. And so here's the t-test. The difference was 3.02. We saw that already. And here's the t ratio. Here's my p-value, two-sided, upper side, lower side. If I want to get this as a randomization test, I just need to now right-click on this output. Any place in JMP where I see output in this table style, I can right-click on it, and I should see Simulate and Bootstrap as options at the bottom. Simulate is going to let me do a randomization test based on that formula column I created. So if I click on Simulate, I want to switch out the sex and switch in the resampled version of the sex. This is going to allow it, every time it switches the column back in, it's going to resample that column. So the randomization is going to happen differently each time. I can set how many of these I want to do. So maybe I'll do 1,000. I can set a random seed if I want to make sure that I can duplicate the results with exactly the same values. I said okay, and it'll just take a second. And so what I get here is first the simulation ID 0 that has this little don't include me. This is the original data. So here was our difference, 3.02. And then the rest of this data set, the other 1,000 rows of this data set, are the differences that were calculated by switching the labels. So now if I go to Analyze and Distribution and look at just the differences, and maybe I'll stack this, I now have a distribution of those differences when I randomized the labels. I see this little red bar marking my actual value originally, my 3.02. And I can even see empirical p-values provided for me here. So here's the simulation results. My original value was 3.02. The probability of something that extreme or greater in both tails is 0.02, and just in one tail is 0.01. So I can see what these empirical p-values are right here. So this is a really great way to do randomization tests from any platform in JMP. I think the only places this isn't available is when you're using REML estimates, and possibly there's one other location. I think reliability. I think reliability might not include this in a few of the options. So in general, across JMP, you're able to, when you get output, like this ANOVA table or this t-test, you can right-click and you can select Simulate or Bootstrap. Bootstrap will, instead of randomly drawing with replacement from that column that I created, Bootstrap will create an empirical distribution by resampling from the actual values in your table, in your data table. So if I chose Bootstrap, I could again ask for a certain number of Bootstrap samples. I can set the random seed or not. I can say okay, again, and it'll take a minute.
Hey, Ruth, while we're waiting, it's available everywhere except for REML and time series.
Time series, okay. Thank you so much, Mia. And so here I see the Bootstrap results. They look, it's the same style of output. So again, the boot ID 0 that has this label that says don't include me. This is my original estimate. So here's my original difference of 3.02. Again, I can go to Analyze Distribution and look at the differences. I can stack this. And I can see the bootstrap confidence intervals here. So the lower limit and the upper limit if I want 95% coverage. And so the bootstrapping and the randomization again are available almost all throughout JMP. And while I have this output open here, or actually maybe I'll use the distribution output. So let's jump back over really quickly. I wanted to show you the p-value animation. So let's go back to some output from the SAT data set from distribution. Let's maybe look at SAT verbal one more time. So in SAT verbal, here where I have the mean, I can again ask for customizing the summary statistics, or I can use this upper red triangle to ask for other options like testing the mean. So I showed you in the help menu under sample data, under teaching resources, there's a way to get this same picture of the p-value. But here, if I just from within the distribution platform, if I try to test against a mean, and my sample mean was 530.7, so maybe I want to test against 528 as my null distribution. I can get a non-parametric test right here. If I say okay, I get this test mean output that actually shows me a picture of what the p-value is telling me. So it says to me the hypothesized, the null value is 528, so my distribution's centered at 528. My actual estimate was 530, and so there's a little red line at that actual estimate. And then my test statistic is 1.6642, so that corresponds to this line if we had standardized this distribution. My two-sided p-value is 0.0968, so that's this piece plus this piece, the area under the curve. The upper p-value is this 0.0484. And I can also use the red disclosure button here to ask for an animation of this. And so here's where I get the same thing. I can see a picture. I get this same information again from the help menu from the teaching resources, but it's also built in directly to the platform here. So here my distribution centered at my 528 because that's what I specified as the hypothesized mean. This black bar, which I can't move, is at the sample mean. There's nothing I can do about the sample mean. It is what it is. But I could test against a different hypothesized mean. So I can drag this if I want to see what if I'd tested against 525 approximately, or something much closer, maybe 530. And if things are running out of my way here, I can use this little bar to move the axis. I can click on high side or low side or two-sided. I can change what would happen if the sample size had been much smaller, maybe 40 instead of 408. And this is built in directly into the platform when you're asking for test mean or test probability. Okay, so we talked about the sample data and scripts that are hiding in the help menu. We've also now talked about some of these teaching aids that are built into JMP, like the p-value animator. There's a power animator in that same location. We talked about the bootstrapping and built-in simulation. Let's also, and we talked about Graph Builder, let's really quickly talk about the profiler, which is very valuable for explaining what a model, what a statistical model is really telling you. So I've just popped open this Titanic passengers data set. I'm going to do a logistic regression with this data set. So I'll go to Analyze and Fit Model. I'll ask to predict survival based on a number of characteristics. Maybe I want the sex of the passenger, the age of the passenger, maybe how many siblings and spouses they have, definitely their passenger class. And I want a model that has some interaction terms in it. So I'm going to say degree 2. I'm going to put 2 second degree interaction terms in. I'll click on macros and say factorial to degree. This puts in all those main effects that I clicked on and all their two-way interactions. I'm going to say my target level is 1, that I want to predict survival instead of not survival. And then I'll click Run. And this does the logistic regression for me. It shows me the most important factors. It shows me p-values for those factors. It gives me a place to remove or add terms, to do a false discovery rate on these. Information on the parameter estimates. Again, anytime I see this table type output, I can right click and I can simulate or bootstrap here. So I can compare these estimates to a bootstrapped empirical distribution, for example. And from the top red triangle, I can also ask for this profiler. You can get the profiler in pretty much any of the analysis platforms. And the profiler will show you, so I'm going to grab the corner of a box and make it a little bigger so it's easier to see this. The profiler will show you, here's the 4 factors that I put in. Their interactions are just going to be implicit in them. There's not a specific box for the interaction term, but you'll see the interaction. So what I have is my response is survival, and I can see that the chance of survival at this specific set of settings, so passenger class 1, female, age 29.881, and 0.5029 siblings and spouses, the chance for a person under exactly those conditions to survive is 0.962, a 96% chance of survival. But I can drag these to change these values. So you can see if everything else stays the same, but I just changed passenger class, now instead of a 96% chance of survival, there's a 90% chance of survival. If I change it again to passenger class 3, only a 45% chance of survival. I can also see from this p-value up here, this less than 0.0001 for passenger class and sex, that there is a significant interaction between passenger class and sex. What that means is that what happens for the effect of passenger class is different depending on the level of sex. So if I look at the shape of this line, the trend for passenger class, and then I switch from female to male, I'll see that that trend line changes shape. That's the whole meaning of an interaction. So I can easily use the profiler to understand different settings and what prediction that gives me, but also to understand interactions and how including multiple interacting variables in a model is going to make it, how I can interpret that by looking at how the passenger class changes depending on the level of sex, for example. Okay, so that profiler is all over the place and is incredibly useful. for understanding what a statistical model is really telling you. All right, so we just have a few minutes left, and that's probably sufficient for me to show you some of the tools that are available on our website. There's a ton there. You're going to want to explore it, and this is where I'm starting to throw in tons of URLs. So if you access this JMP journal after this webinar, you'll be able to click directly on any of these links to get immediately to these tools. So a lot of tools like DOE, if you're teaching design of experiments, we have a lot of design of experiments case studies, and so there's a lot of information that you can get by clicking on this. Again, design of experiments, there's some info kits for teaching design of experiments in chemistry. So a lot of these tools are very specific. If you are teaching with JMP, I would definitely recommend looking through this list. There's so much that's hiding on our user community and on our webpage, and so I'm trying to give you a chance to see just sort of a smattering of what's available. But let's go over to our webpage. The JMP academic webpage at the top. So if you go to jmp.com/academic, at the top you'll see some extra information about JMP. Why use JMP is a great place to click if you are considering using it in the classroom and you want some more ideas. The JMP screenshot gallery is a great place to go if you just want to see the kinds of things JMP can do. But if you go to jmp.com/teach, it's going to take you to the same page, but it's going to center you right here. So jmp.com/teach will take you here. And you'll see a lot of tools on learning JMP. So if you click on getting started videos, you'll find some short, maybe 15 to 25 minute videos that are designed especially for new users that'll show you sort of a tour of JMP and what to do and how to use those red triangles and some of the stuff that I've covered today, but with a little bit more depth. The learning library, this is a really great place to go if you're teaching or learning JMP. If you want to learn about how to do a regression in JMP, for example, you can click on the correlation and regression category of the learning library, and there's a one-page PDF talking about how to get a correlation in JMP. So if you click on the one-page guide, that'll just download a PDF of one page showing you here's a sample data set that you can open from our sample data library, and here's exactly what you do to get a correlation. And there's also a 2 to 3 minute video for most of these one-page guides. Sometimes there's also a tutorial that's online that you can walk through. So a lot of ways to get the same information about how to get a correlation, or how to get a non-parametric correlation, or how to do a simple linear regression. So we've got, I think, about 80 of these one-page guides, and they're all available from our teach, jmp.com/teach, right here in the learning library. And then the academic webcast, this is where you'd go to find the recording of this webcast or to find this JMP journal with all these links in it. Course materials, the case study library, these are fantastic sort of longer case studies. So you can download them in bundles, all the business stats, all the regular like intro stats, all the analytics case studies. And so, for example, analytics and predictive modeling, there's a case study on bank revenues. So there's a little short summary here. A bank wants to understand how customer banking habits contribute to revenues and profitability, and we want to build a model. So you can download the case study and the data set right here, and these are really great examples, especially for teaching. So the case study library has a lot of really great examples for teaching. The learning library has really good guides to help you get started. JMP e-learning courses, this is where you can go if you have the academic suite at your school, then you have access to these e-learning courses. And some of these courses will even print a certificate. So if you're teaching, you might assign students to take the 2-hour e-learning course, and then at the end they print a certificate and bring it, and that's their first homework assignment, for example. Books with JMP just gives you a list of some books that are using JMP in the book, or that are have a textbook add-in, for example. And the textbook add-in, again, you just download this, you just click on it, and then you save it to your desktop, and then you open it in JMP one time, and then it just lives up here in the JMP add-ins. So you can look through books that are using JMP. The teaching resources, the interactive learning tools are the things that are built into JMP. We already looked at these. These are all built into JMP. But you can also download them as an add-in if you want to have them in your add-in top-level menu. The calculators we also looked at, and there might be a couple of extra things here on this web page than just built into the software. AP Statistics has a bunch of resources, including JMP intro lab activities. So even if you're not teaching AP Stat, but you're teaching JMP or intro stats, there's a bunch of intro stat lab activities that are available here that are really fantastic for using in like a lab course with teaching JMP. And student assessment is a place to go to find some interactive JMP questions. I think we have a question bank of about 150 questions in WebAssign. So if you are using a textbook or you have a school license with WebAssign, you can get a bunch of JMP assessment questions right in WebAssign. Okay, and then very, very briefly, I'm just going to tell you, you should go to our user community. You can get to it from the help menu from clicking on JMP user community. It will take you directly there. And you can search for things like randomization test if you want to find that add-in, for example. But there's also, again, if you download this journal, you'll have all these links. There's a bunch of course materials that professors have contributed on the user community. So if you want to teach modeling and data mining, for example, there's some course materials posted, intro to time series. So this is another great place to go to see what other users have contributed, and maybe at some point contribute yourself, your syllabus for a course or materials you're creating to help other professors do the same kind of things in JMP. Okay, and then highlights. I love this JMP Academic 360. This is from our main academic webpage. Click on this if you want a reminder of just the breadth of things JMP can do. Definitely go back to the JMP help. We spent a lot of time here in this sample data and teaching resources. It's really valuable when you're teaching intro stats. It's all just built right into JMP. The webinars and videos from our webpage, jump.com/teach, the learning library from jump.com/teach, the case studies, all that sample data and interactive demos, again, from the help menu, and our user community is fantastic. So if there's anything I can help you with, please send an email to academic@jump.com or directly to me at ruth.hummel@jump.com, and I'd be more than happy to point you to resources or find you other things or tell you how to contribute an add-in on our user page or anything like that. So thanks again for joining. I really appreciate you being with us today.